It turns out that we can write out factoring by grouping using that rectangle method that we saw for multiplication, essentially just running the multiplication backward. And this actually makes a lot of the details of factoring by grouping, especially things like negative signs, a lot easier to keep track of. So let's see how we could do this. I'm going to take my polynomial with 4 terms. I know I want to write it as a product of 2 binomials. So I'm going to put these 4 terms in the 4 smaller rectangles of a rectangle with 2 rows and 2 columns. So there's my first step. Next, I'm going to look at my first row, and I'm going to factor out the greatest common factor. So here I have p squared, whose only factors are 2 copies of p. Here I have a factor of p, so my GCF for my first row is p. Now, I can actually use division to fill in the remaining spaces. So for this space, I want to say p times something gives me p squared. That something is another p. For this space, I want to say p times something gives me 3ps. That something is 3s. For this space, now I'm going to say this p times something gives me negative 2pq. So that'll be negative 2q. And then, so notice I've used this, and this monomial. So far I've ignored this. The last thing I'm going to do is check that the bottom right product works. Right, so 3s times negative 2q is in fact negative 6qs. So my polynomial, p squared plus 3ps minus 2pq minus 6qs, factors as p minus 2q times p plus 3s. And multiplication is commutative, of course, so it doesn't matter which order you write the factors in. So using the rectangle method, doing multiplication backwards, gives us, in many ways, an easier way to factor by grouping. And in particular, we're less likely to make mistakes keeping track of negative signs in this method. So let's see another example of this process. We'll start out by making a rectangle with 2 rows and 2 columns. And then I'll copy my 4 terms, 2x to the 5th minus x to the 3rd plus 10x squared minus 5. I will look for the greatest common factor in my first row, which this term has no coefficient. Its coefficient is plus or minus 1. So I'm just looking at the x's. X to the 5th, x to the 3rd, x to the 3rd is the smaller power. X to the 3rd times what gives me 2x to the 5th? Well, I need a 2 and 2 more x's. X to the 3rd times what gives me negative x to the 3rd? Well, that's just a negative 1. 2x squared times what gives me 10x squared? Well, that must just be a 5. And then I'll confirm negative 1 times 5 is in fact negative 5. So our polynomial factors as x to the third plus 5 times 2x squared minus 1.